Okay, can you hear me?
Yes, I can hear you.
Okay, just you're waiting 1 minute, then we'll start.
All right. Did your background is different?
Yes.
It looks like you're driving.
Yeah. So now I am in my village. So yesterday I come back village.
Okay.
Okay, network is also okay. There is no problem, I hope. But sometime it also issue for the
Hey,
village network is not much good.
yeah, your network is good, so I can hear you loud and clear.
Okay, thank you.
Oh, hi, Holly.
Hello, Aman. Good evening, bro.
Greetings. Good evening to you.
Nice to see you,
Welcome back.
sir.
Yeah, thank you.
Nice to see you too.
How are you, bro? You are good?
All is well, all is well. But the
Alhamdulillah.
Google Earth Engine codes are not easy.
Yes, it's too much difficult, but it's okay.
Yeah, we shall learn slowly, slowly.
Yeah.
We can learn slowly, slowly. Yes.
Yeah, just
Step
make
by step.
practice. Okay. Then I
Practice
hope.
makes
Yeah.
perfect. Sir, is it possible to publish any article with
Yes,
you?
yes, yes. So related this type of topic, if you want, you can also make the collaboration for scientific paper. Okay, then you
Yes.
can also get the support. Okay, suppose some part I
Thank you so
make the
much.
analysis and some part you also make the writing part or analysis part, then make the collaboration, then you also make the publish our scientific paper regarding the air quality monitoring or urban heat island or urban thermal
Urban
field
age,
incident, land use land cover.
yes,
Yeah,
yes.
this type of things we can easily do after completing our online training program, no problem.
Thank you so much, sir. Thank you so much, Manila. Thanks.
What kind of conditions do you give?
There is no condition. Like you try. I hope I also guide you. No problem for this type of analysis. And I hope after completing this online training program, you are able to do land use, land cover. You can also do for flood monitoring, or you can also do urban heat island or LST monitoring or urban thermal field variance index or air quality monitoring. Okay, so today we talk about the air quality monitoring. Okay, and then for change detection analysis for the different time decade, we also discuss about this type of further class. Then you can easily do this type of analysis, no problem. Okay, okay, so we will start today's session. Okay, after completing this session, then you talk about the problem solving class for previous classes. So let me share my screen. Okay, can you see my screen?
Yes,
Okay, so
clear.
okay, thank you. Okay, so basically today is our fifth number test, and today's session we discuss about that air quality monitoring. So all of parameters such as nitrogen dioxide, sulfur dioxide, carbon monoxide, formaldehyde, or methane. So this type of gases, how we can easily monitor using remote sensing technique, as well as how to download the air quality parameters data in a CSV file format. We already make different types of time series chart, and from the time series chart we can easily download the CSV file. But sometime this CSV is not work, we face some problem. Okay, suppose when you work with big study area, there are the lot of pixel, so that's why it's not compute the time series chart. Then we try to directly download the data as a CSV file from Google Earth Engine. Okay, so today's session I also discuss about that how we can easily download the time series data in CSV format directly without creating the chart. Okay, and also discuss about the time series chart for air quality parameters, different types of parameter we also discuss, and air quality, how to calculate the total emission. Suppose for a specific month or a specific year, how much gases is emitted. Suppose what the how much nitrogen dioxide gas is emitted in a particular time period for a specific region. So this type of emission calculate, we also calculate this type of things, and also discuss about that AOD, basically aerosol optical depth, how we can easily monitor, and also how we can easily monitor the particulate matter 2.5. And also today's session will discuss about that ArcGIS, mainly ArcMap. So how we can easily download the data. So we already download the different types of GeoTIFF file format from Google Earth Engine. So this type of GeoTIFF file format, further we also use the ArcMap or QGIS software to make the better map for our research paper or presentation. So today's session will discuss about that, how to download this type of data, and then how we can easily make the map using ArcMap or QGIS software, as well as accuracy assessment. Suppose you create the map, nitrogen dioxide density. So now how we can easily check the accuracy of our air quality parameters map, we also discuss about that, and also discuss about that how we can extract the points pixel value for a specific geolocation. Suppose I have some ground truth geolocation. So now this type of ground truth geolocation data, I want to extract the point pixel value, I want to extract for a specific geolocation. It's very helpful for the different types of work. Suppose you visit some study area and now you want to extract the remotely sensed data for this type of specific point, mainly specific latitude and longitude value. Suppose you have a CSV file. This CSV file, you collect some ground truth data for air quality monitoring parameters. Suppose nitrogen dioxide. Groundly, you collect this type of data. So now this type of data you want to compare with satellite imagery. So for that, we need to import the specific latitude, longitude values on Google Earth Engine, and further we extract the data from satellite imagery. Okay, suppose nitrogen dioxide or sulfur dioxide, okay, which we generate from satellite. Then we try to compare, and further we simply calculate the correlation for our ground truth data or our satellite imagery data. Okay, and also check the accuracy. So this type of thing we also discuss about that, how we can really do, and also discuss about the trend analysis. Suppose I have a time series data, 20 years data or 10 years data or 5 years data. So I just use this type of data, and further I want to find out the trend. So what's the trend for the emission of nitrogen dioxide? What's the trend of emission of sulfur dioxide, or any trend? Basically previous data, I have suppose 10 years data or 5 years data. So this type of data I just use, and further we try to find out what's the trend. It's the high trend or low trend, or it increasing day by day or decreasing day by day. So this type of things we also discuss about that, and how to apply the linear regression in Google Earth Engine. We also discuss about that, y equal to mx plus c. So this type of linear equation, how we can really apply on our data, and then we predict something. So let's go ahead to discuss all of things step by step. Then I hope you can easily get the idea about all of topic. Okay, so let me open a new code editor. Okay, so first of all, okay, so you simply click on the browse data catalog, then we can find out all of data. Basically, it's provide the Sentinel 5 tropospheric instrument. So this data. So from this data, we can easily access all of air quality parameters, as well as we also use at the MODIS satellite data to extract the AOD, mainly aerosol optical depth. So you can see this is the one kind of data. It's called the Sentinel 5P. So it's provide you aerosol index data, then Sentinel 5P cloud data. We also find out the carbon monoxide data. Okay, then formaldehyde data, We also find out the nitrogen dioxide data or ozone data, okay, sulfur dioxide data, methane data. And this type of data can be two types. You can see it's the offline, another is the near real time, NRT. Near real time data is more update data, okay, more near time, okay. So it's a more update. And offline, it provide you with a more basically not mass update, okay, it not mass update, suppose before 3 days, this type of things. But near real time, it provide you the update data, more update data, two types data. So if I check, suppose for the nitrogen dioxide near real time data, click on here. So now it provide, you can see what is the last time period. So this is the 25/05/29, okay. So now here 30, so 29, this is the last time period, this is the last update data. And this is the NRT, you can say NRT, basically near real time data, okay. But if you check for the offline, okay, suppose offline, so it provide the, you can see 20, okay, 20, this is the last time period, offline nitrogen dioxide data. So basically for some time we also need to work with near real time when you monitor for update data, more update data, okay. But this offline data set is more accurate, okay. So basically it's also provided with a more accurate pixel value, greater than your near real time data. Near real time, it provides with the more update information, but it not much accurate than offline nitrogen dioxide data. So it provide you, so you can see now for this nitrogen dioxide, offline nitrogen dioxide is available from 2025/05/20, okay. But near real time data is available from 29, okay. It's more update data, we can easily find out. Sometime for different types of region, for forest fire or any specific hazard, then we need to monitor how much nitrogen dioxide gas is emitted for the forest fire. So then we need the immediate data or more update data, okay. So for this type of case, we are using the near real time data and monitored the near real time condition for forest fire, how much gas is emitted, okay. So let's go. And both are the same process when you work with offline or near real time data, both are the same process, okay. So let's go, we try to work with, suppose I want to work for nitrogen dioxide and I want to choose, suppose, offline data, okay. So this data set, we can see this is the snippet ID about this data set, and this is the resolution about the data set, pixel size 1113.2 meters. And here you can see this is the one kind of band name, so nitrogen column number density. So this is the total vertical column of nitrogen dioxide, and this is the unit, mole per meter square. So this is the unit. And also you can see this is another band, it's the tropospheric nitrogen column number density, tropospheric vertical column, then stratospheric, okay. So tropospheric, then stratospheric, so different phase. So I want to monitor, suppose density of nitrogen dioxide, this is the total vertical column of nitrogen dioxide. So I want to use this band, and further I want to make the density map of nitrogen dioxide. So same as, just simply copy this snippet ID and then paste on your code editor, and then just give a variable name. You can put any name as a variable. Suppose I put the name as a dataset, okay. Okay, so just simply import our dataset in our code editor. Then we need to import our study area, okay. So which area you want to monitor. So I want to work, suppose if you want, you can simply import your shapefile in your asset tab, and then you can also import your study area. So I want to choose one dataset, FAO. So basically it's provided with the level 2 study area, level 2 shapefile. You can easily find out, you can see the second level administrative area, just import. So then I filter and choose my specific level of level 2 data. So for that, just I take a variable. suppose I put the name as the RY, and this table I want to filter and choose the specific area. Okay, so art engine dot filter dot equal what's equal what. So this information we can find out in the dataset information, you can see. So I want to choose, okay, Lahore city, no problem. So I choose suppose level 2 name, level 2, and then paste here, and then put, you can any level 2 city name. Okay, so what I put here that Lahore city. Okay, so now try to add the layer, then check the shapefile of your boundary area. So RY, and also focus. Okay, but okay, Lahore city, there is no level 2 data. Suppose level 1.
Excuse me.
Yeah, please.
They don't specify only the names or study areas under level 1 and 2.
Level 1 basically it's a division. Okay, and level 2 is the district name.
Yes.
Suppose
Yes, what I'm saying.
yeah,
The lists are not there.
suppose we try to for Punjab, then check what happened. Punjab is available, you can see. Okay, so this Punjab, and if I try to check for suppose level 2 of Punjab, then it's not available for that, but level 1 for Punjab. Okay, basically Lahore is the capital and largest city of the Pakistan province of Punjab. So in the Punjab, if you check, so this is the Lahore. Okay, but if you try for level 2 of Lahore and run the code, then you can see it's not available. Okay, so then we try to add here, download the data from global administrative level dataset, and then it will be worked. Okay, because some area is not available in this type of data, so that's why we can also download the data or shapefile from this website. So I simply search, so this data, yeah, so from here you can easily get all of level shapefile boundary. You can see the data, just click on here data and country, and from here choose your country. So all of country is available in here. So then simply download the data and then import in the Earth Engine platform and then work with that. Okay, so then we can easily get all of administrative level area, then we can easily work with that. So you can see the level 0, then 1, then 2, then 3, then 4. Okay, so maximum is available from the level 3. Some area is also available level 4. Okay, so this type of data we can download from here, and then we can easily choose our specific boundary and then work. Okay, so what I want to work with this study area Punjab, and then I want to monitor, suppose air quality monitoring of nitrogen dioxide. Okay, so let's go. So here we already import our data set. So this is our data set. and this is our study area, and this is the data set. So now this data set we need to filter, right? So you can see it's a image collection, okay, and this image collection, first of all, you can see this image collection have some bands, but I want to work with these bands because I want to monitor the nitrogen column number density. So just simply use a function, select function, and select the specific bands. Okay, this is my band name. I simply select it. Okay, and then just we need to filter the data. Okay, filter for a specific time period. So just use here filter date function and put the specific time period, suppose 2024, suppose 1st January. So I take the only 1 month data, suppose 2024 January 31. Suppose for this month I want to monitor, and then also apply here dot filter bounds function and with our ROI shapefile, okay, filter bounds. And now if you check how many images are available, just print and then call the dataset and use the size function. So now it's computing the total number of image collection. So we find out 417 images we find out for this time period for this study area. So now this is my image collection and I want to use it and make a time series chart. Suppose I want to make the time series chart between month of January, when the nitrogen dioxide is high, when the nitrogen dioxide is low. I want to monitor these things. So for that, just make the time series chart. We already know about the time series chart. So simply search here ui.chart.image. So then you can easily find out all of function related to the time series chart. You can see. So I am to use ui chart image.series. This is the function. So you can see this first argument is image collection. Okay. So I find out total 417 image collection, and it is stored in a variable. This variable name is the dataset. Just copy the dataset and paste here. Then region, your shapefile variable name. So just put here ROI reducer. So how I can reduce it? Suppose I want to compute average or maximum or minimum emission of nitrogen dioxide. So I choose average. So reducer dot mean, and scale is the resolution of your satellite imagery, 1113.2 meter. And then X property, we just apply default system time start always. Okay, just put here the system time start. So now it's all of those things just stored in a variable. For the variable, just put here the var keyword and give a variable name, suppose chart, then equal. So now just print the chart, and run the code. So you can see find out this type of time series chart, but this time series chart have a problem. Okay, if you check it, it show the null value. You can say 0. Okay, it show the 0. So it's one kind of common problem in Google Earth Engine. So basically when you work with this type of data, so this unit is the mole per meter square. Okay, so mole per meter square. So this value is very low value, very low value, inverse 5 or inverse 8, this type of very low value. So that's why in Google Earth Engine it show the round figure as a 0. Okay, but this type of place we have a value, but when I just keep in mole per meter square, then we face this type of problem. It show the null value or it show the 0. You can see all of point, all of place, it show the 0. because this unit is mole per meter square, but this value is very, very less. So that's why it show the round figure as a 0. So now I just convert the unit. So it show the mole. If I convert into micromole, so then we find out the value. So this is the one common problem. So when you face this type of problem, generating the data or time series chart, so it show the 0 when I use the mole unit, mole per meter square, because you can see this is the mole per meter square. So that's why it show the 0 value, because if I keep the data as mole per meter square, it's very, very less value. Okay, inverse 5 or inverse 8, very, very less value. So that's why it show the 0. Okay, so that's why we need to convert the unit mole to micromole. So when I convert this unit mole to micromole, then we find out the value. So now how I can convert mole to micromole? So let's go. We try to convert the unit. So I simply search here mole to micromole. So you can see the multiply the amount of substance value, this value. Okay, so this value is simply multiply. So when I multiply this value with this all of images, then it convert as a micromole. Okay, and this is the value. So this value I want to multiply, then we find out the micromole unit. So let's go try to multiply. So now all of images, how much images? 417 images. Okay, this is the total image, and this image unit is mole per meter square. So now I want to multiply this value and convert the unit micromole per meter square. Okay, so now at the same time I want to multiply all of images. At the same time I want to multiply all of images. So that's why we are just applying a function. So we just create a function. This function help you to convert the unit from mole to micromole. So just we try to use a function and multiply all of images together. Okay, so let's go try to create a function. So we already know about the function. So for that, just take a variable. I put the variable name, suppose micromole dataset. You can put any name, and then function keyword. You can put any name. Put the function keyword, and then put the element name. So you can put any name as an element. I put suppose img, and now I put my argument in this bracket. So I want to use this image. So this image I want to multiply with this value. This value I want to use and multiply. So let's go try to multiply. So for that, just use the return function. Return this image, multiply this value. Okay, so when I multiply this value, then this image convert mole to micromole. So now I just use only for the one element, but I have rest of the other images. So for that, we need to apply a function. It's called the copy properties. Copy properties. Okay, I want to copy these properties of this element, and these things I want to apply system time start to system time end. So just I apply. So you can see just I create a function. So in this function, I take a variable name. You can put any name as a variable, then function keyword, and I put the element name img. What is my argument? My argument is that this element I want to multiply this value. Why I multiply this value? Because I want to convert the unit mole to micromole. Because if I keep the mole, then it show the very, very less value, and it show the round figure as a 0. I need the value. So for that, I simply convert mole to micromole. Okay. So now we find out this is the function. So this function I simply connect with my collection, total 417 image collection. So how I can connect? Very easy. Just copy this collection. It's a collection. It is stored at 417. So this collection I want to connect with my function using the map function. Simply connect. So now it stored the image collection, but in this time all of images multiply with this value, and when I multiply with this value, then it convert as a micromole. Okay, so let's go try to print the chart using this dataset, new dataset, and run the code. Okay, so now we find out this type of time series chart. Now if you check, it give you the data. So we find out, you can see that January 5th, we find out the data 78.308 micromole. So you can see, now we find out the data, all of data is available. But previous time when I keep the data as a mole per meter square unit, then it show the 0, because it show the very low value, and Google Earth Engine automatically show the round figure. So that's why we simply convert the unit mole to micromole, and for converting this unit we are just use this function. Okay, this function. So now we find out this type of data. So now suppose I want to add some other option about the chart. So for that, just use here dot set options and add some others, suppose chart title, other things. For the title, just add the title, suppose time series, and add the vertical axis, add the title. Suppose I put the title, it's a micromole per meter square, and then horizontal axis, put the title, it's a time or day. Okay, we put the time, and now run the code and check what happened. Just run the code. So now you can see, find out this type of chart. It show the line breaking chart, but previous time without adding the title or adding the X level Y level title, it looks more better. But when I add the chart title or Y level X level title, then it show this type of line breaking chart. But I need the continuous chart, okay, not line breaking. So you can face this type of problem also in Google Earth Engine for other dataset also. So basically it show the line breaking when you add this type of element such as chart title, X level, Y level title. So for how I can fix this issue, so for that you need to use another argument. It's called the interpolate nulls. Just open, put here the true. Okay, just put the true, interpolate nulls true, and then run the code. So now all of null value automatically remove, and then it create the continuous chart, line chart. So now I can see it's again look more better. Okay, so now we find out this type of chart. It's not line breaking. Okay, so this is the way to create the time series chart. Suppose I want to check the trend. Okay, what is the trend? So suppose this is my data. So if you have more 5 years, 10 years, so any data. So this type of data I want to use, and further you want to check the trend. What's the trend of nitrogen dioxide for this Punjab? Between this, using this 1 month data, we try to check it. It will be decreasing or increasing. Okay, so it's how we can easily add the trend. For the trend, when you make for any time series chart, when you make the trend line or make the trend analysis, then we need to apply another argument. It's called the trend lines. Okay, just put the trend lines and then put all of things for the trend lines. So now it just only one line. You can see only one line. So this one line, based on this time series chart, I want to make the trend. Okay, and it's only for the one. In JavaScript, 0 is refers to the first item. Okay, 0 basically first, so 0 basically 1, so basically it's the 1, so and 0 refers to the first item. Okay, so just we put at the 0 and then we apply here the type. So different types of trend analysis you also do. Suppose linear trend line analysis or polynomial or exponential. Suppose I want to apply the type is a linear, and then just run the code and check what happened. Just run the code. Okay, so you can see we find out this type of trend line. So you can see we find out this type of trend line. It's the uptrend. You can see this trend line is increasing, so it's a uptrend, not low trend. You can see, right? So we are just consider only for that 1 month. So when you do for the 5 years data, 10 years data, or when you add the more data, then it will look more better. Suppose I have to add the color of the trend line. So for that, just put here the color and apply suppose red and run the code. So I guess we find out this type of trend. Right. So you can see it's the high trend. Okay, so we can see it's not down, it's the upward. So this trend line is upward. So it means that day by day it increasing the emission of nitrogen dioxide. As well as if you want, you can also add here the another style of your trend line. Suppose if you want, you can also use here the line width. Suppose I put here the line width is the 3, or put here the suppose 6. Run the code. So now it also increasing. As well as you can also add the opacity. Suppose opacity. Suppose I put the 0.2 opacity. Then if you want, you can also add here. I can see now it also show this type of chart opacity. You put the 0.2. If you want, you can also use at the trend line legend. So put at the visible in legend. So just open, use at the true function, just run the code. So now it also add the legend for trend line. So you can see it also add the legend. This is the trend line. We also find out in here. Again, this is the time series chart, nitrogen dioxide. Okay, so based on this time series chart, we check the trend. So it show the uptrend. So this is the way to make the time series chart and check the trend. So you can use the same code for any other time series chart to check the trend. Okay, you can use the same code. Suppose I have a data for NDVI. So now I want to make the trend for NDVI. Suppose I have a time series chart of EVI. So just apply the same process and check the EVI trend. Just apply the same code, then you can easily check the trend for any data set. Okay, So now I want to visualize the map. Okay, I want to visualize, and then we check which part have more density of nitrogen dioxide, where the low density, where the high density. So this type of place we try to recognize from the map. So let's go try to display the map. So it's very easy, just take a variable, and I want to calculate, suppose, average density of nitrogen dioxide between this time period. So just I put here, call the dataset. So I want to create this map using the micromole. Okay, so micromole. So just I call the micromole dataset and paste here, then apply here the mean function. So now it's computed the average pixel and clip with our study area, which is ry. So now we try to display map.add layer and call the mean no2. Just copy and run the code. It look like this type of map without color. So we try to add the color. So we can easily find out some color code. You can see they also provide this type of color code. Just a copy and paste here. Then okay, just we try to stress the data to look more better visualization. Just make the stress, suppose 98% I keep. So now it automatically provide the mean and max range, which is more better for the visualization for micromole. Okay, so it show the 46 point something micromole mean and max 246.58 micromole for the max value. And then copy this variable name and paste after the object name. Just run the code. So now it also added the color. So you can see find out this type of map. So basically this type of place, it's red color indicating about the high density of nitrogen dioxide. Black is indicating about the low density of nitrogen dioxide. Okay, so you can see find out this type of place. Also this type of place, we find out that high density of nitrogen dioxide gases we find out. Okay, if you want you can also decrease the opacity. Suppose just click on here and opacity, just I simply decreasing and apply. So now it looks more pretty. Okay, so we can find out, just apply this type of opacity. So when you just decrease the opacity, then this map is also visualize the base map. Okay, then it look more better. So you can find out this type of map. Okay, so here you can see this type of place, it show the high density, and you can also compare the color. You can see the color ratio. So this type of place, red color, it show the value 246 or greater than 246, this type of red color. Okay, and this type of black color, we find out the result 46 or lower than 46. Okay, 46 or lower than 46, this type of red color. So you can see it gradually increasing. Okay, so greater than then greater than this, greater than this, greater than this, greater than, and this is the highest value of density. So we find out this type of map. So if you increase, then you'll check the result. So for this place, we find out that you can see, we find out that more density of nitrogen dioxide. Okay, this type of place. Also you can see this place, basically for the city, this type of place, we find out the high density of nitrogen dioxide due to the vehicles emission. So you can see we find out this type of red color indicating about the high density of nitrogen dioxide. We find out this type of place. And this is the result for month of January 2024. And we can also do, suppose, for the precipitation, how much nitrogen dioxide is low or increasing or decreasing. So this type of things you can also research. So you can simply compare for the seasonal, okay, air quality monitoring, suppose rainy season or summer season. Okay, then we try to compare. Okay, so which season we find out the more density of nitrogen dioxide, then we need to compare this data with precipitation data or rainfall data. Okay, then we compare. So you can also try to explore these type of things, then it look more interesting. You can also make the research paper regarding this type of topic also. Okay, so now this is the way we create this map, and then we can easily just make the download the data GOT file format, and then use the ArcMap or QGIS software to produce the map. Okay, so this is the way to working with this type of data. But in this case, suppose I just increase the time period, then check what happened. Okay, so let's go. So I want to monitor this data from year of 2020. Okay, 2020 from 2025. Suppose this is my time period. So now let's check what happened just on the code. So you can see it also increasing the image collection. Total number of image collection, it also increased.
Excuse me, sir.
Please.
For critical time, can I make comparison like 5 years, like 2020 up to 2021, and next year 2021 and 22 up to 2025? Each year, can I get separate image?
Yes, it also possible. Yeah.
Okay, can I get difference for each picture?
Yes, it also possible.
Oh, okay, thank you, sir.
So now you can see when I just increase the time period, it show a problem. This problem is that it cannot be loaded the chart. Okay, so this is the common problem on Google Earth Engine. So it one kind of limitation of Google Earth Engine. Okay, so this type of problem we can handle without creating the chart. We are directly download the data as a CSV file. Okay, we directly download the data without creating the chart. Okay, and from the CSV file data, we can easily make the time series chart using Excel. Okay, we can easily make the time series chart. So now you can see it also loaded. Sometime it show a problem because there's a lot of data between this time period. Okay, and it cannot be calculate that time series chart for the big data. So for that, we also need to learn about that CSV file extract from here. So how I can download this from this time period all of data at the same time using the CSV file without creating the chart. Okay, so let's go try to discuss about that. So basically in the CSV file we find out this type of value. Suppose is column, it's some column, and in the column suppose date and value. Okay, so we need to create this type of function. So this function give me the column for date and also give me the another column for value. Suppose 1st January, what is the value? 2nd January, what the value? 3rd January, what's the value? So it give me the value for each date. So for that, just take a variable, suppose CSV, and create a function. Just put here the function and put the elements img. So just I use this element img, and further I want to put my argument. So my argument is that I want to calculate the average value for each day for my study area, as well as I also extract the date from this image. From this image I extract the date as well as I also want to extract the average value for each date. So this is my final argument. So first of all, I want to extract the date. So for that, just take a variable, suppose date, and then put here image dot date. Okay, so just I call the element name and put here the date. So basically this function extract the date, and further we can put here the format. If you want, you can also define the format, suppose year, and put here suppose month, and also put here the date, or you can put the default. Okay, not need to add anything. It show the default date and time, no problem. Okay, so these things we simply extract the date from this element and also just add the format function, and now we compute it for each image's average pixel for each date. Okay, so just take a variable, suppose stat, and then call the element name and apply a function reduce region. Okay, this function is simply apply and put the all of argument. So first argument is the reducer, so put here the reducer and apply here ee dot reducer dot mean. So now it's computing average, and also put here geometry, it's your shapefile variable name ry, then put here the scale 1113.2 meter. Okay, so you can see we face this problem, error generating cert computation time out. Okay, because now I apply the more data. Okay, so when I compute the big data, it shows this type of problem, it not generating the chart. So you also face this type of problem, not only for this data set, any data set. When you face this type of problem, then we try to directly download the CSV file using this way. Same way, you can also apply and directly download the data as a CSV, and further just download the CSV file from here. So let's go try to download the CSV file from here. So just I compute. So you can see this is my first argument, I extract the date for each images, and this is my second argument, I just extract the average value for each image. So now I just use these two variable and make a dictionary. So for that, just take a variable, suppose dict, and make a dictionary, suppose date, and also date, and also put here that stat, same stat. Okay, just we make a dictionary. Okay, so this dictionary, so every function we will use a return. So basically what I return from this function, so I want to return this function as a feature. Okay, so basically in the CSV file, it's considered as a feature, null feature. Null feature means that there is no geometry, but this have a data. So in this time we are not extract any kinds of geometrical or geometry or polygon information. We are not extracting. We are not extracting any kinds of geometry. So that's why it's called the null feature. We are just extracting the each day's average value, each day's average value. So just I return ee dot feature, but in this case there is no data. There is no data for geometry, latitude, longitude not mentioned. So for that use at the null. Okay, and then it's set with dictionary dict, just call this variable name. Basically these things is extract the it used for it, this is the one kind of data type feature, but now there is no feature mainly point line polygon, there is no information for the point line polygon. So that's why I apply here the null function and set with this dictionary. So basically now it just storing the information date and average value for each date. Okay, so let's go. So it's one kind of function. So this function we are just connecting with our image collection. Okay, so we already check how many image collection. You can see we have total this large number of image collection. So now I just simply connect with my image collection, then it will be work. So now how I can connect? Very easy, we already know. Just simply call this variable, which variable stored this image collection. Okay, which variable stored this image collection, just call this variable name, and then we simply